Okay, section 6.1, number 6. And we're supposed to find for what values of A is the area between the curves equal to 2. So what do these curves look like? So first of all, this F looks like a parabola that's upside down, moved up 1. So I'm going to put 1 up there, I'm going to put 1 over there, put 1 over there, and it's an upside down parabola. So it's going to go through 0, 1, 1, 0, and negative 1, 0. And negative 2, negative 3, and negative 2, negative 3. So it's going to look something like that. Okay. All right. Now what's this one look like? Well, it's a right side up parabola moved down A and stretched by an A factor. So it's a right side up parabola. And I'm going to do this in pencil so we don't know where it's going. But it hits this curve someplace. We're looking for those places. So to find those places where they intersect, we'd set these equal to each other. So we'd have 1 minus x squared equal to a x squared minus a. Now, what happens here is I could solve this by subtracting x squared from both sides or adding x squared to both sides. I'll do that. I'll add these over and subtract the 1, so I'd get 0 equals a plus 1 times x squared, because I have a x squareds plus 1 more x squared. And I'm going to have minus, and I'm going to have a minus, I'm going to have minus a minus 1, which is minus a plus 1. And so I have a plus 1 in both these, so I have a plus 1 times x squared minus 1. And when is that equal to 0? Well, it doesn't have a variable. It'd be equal to 0 if a was minus 1. If a was minus 1, it would be the same as this curve, and there would be no area between them. Or when this is 0, which is at x equal 1 or negative 1, which means this curve that I was sketching here doesn't go through just any place. It hits also at 1 and negative 1. So it fits in here. Okay? But we still don't know what A is. Now, we're looking for the area between the curves. Okay? Now, there's several things we can do here to find this, but let's just do is just in general. So I'm going to make a vertical slice, because that way it stays the same. If I do horizontal slices, then I have to do between the curve and between the curve, the positive and negative, and I have to solve these for x equal if I go this way, and that's not so nice. This way is nice and easy. The width then would be dx, and I would find the integral from my x's are going to go from minus 1 to 1 of this curve, which is this one, minus this curve, which is that one, dx. Now, this is not terribly difficult to do. The antiderivative of 1 is x. The antiderivative of negative x squared is negative x to the third over 3. The negative, then we got negative of this, so the antiderivative of that would be ax to the third over 3 and the negative makes plus, and the antiderivative of a would be ax, evaluated from -1 to 1. So I would put in 1 in for all the x's, and I get 1 minus 1/3 minus a thirds plus a. That's putting 1 in for all the x's, minus, I'm going to put minus 1 in for all the x's, so that becomes -1 plus 1/3 plus a thirds minus a, putting -1 for each of the x's. This works out to be 1 plus 1 is 2, minus 1/3 minus 1/3 is minus 2/3, minus a thirds is minus 2a thirds, and plus a minus a is plus 2a. So combining the a terms, I have, and combining the constants, 2 minus 2/3 is 4/3, and 2 minus 2/3 is 4/3 a. And they wanted the area to be 2. So I'm setting this equal to 2, and I'm solving for a. So I will subtract 4/3 from both sides. A minus 1 1/3 is 2/3. Dividing by 4/3 on both sides. I get a equals 1/2. Okay, now let's be a little smarter about this. Okay, if the area between these two curves has got to be 2, then the area here, between here and here, that has to be, just this one side has to be 1. If the both sides is 2 and this is symmetric, that has to be 1. And if I figure out this area between this curve and there, I know what that area has to be. So I'm going to do that. And so the area under this curve, this one would be the integral from 0 to 1 of 1 minus x squared dx. And that would turn out to be x minus x to the third over 3 evaluated from 0 to 1. Putting 1 in there, I get 1 minus 1/3 minus, putting the 0 in, 0. So I get 1 minus 1/3, which is 2/3. So this top part has an area of 2/3. So the bottom part has to have 1/3. Half as much. Now, if this curve goes up to 1 and has 2/3, then it has to go down to a half to have 1/3, half as high, so there'd be half as much area. And to make this go down a half, A would have to be 1/2. So that would be a shorter way of a nice reasoning graphically how this would have to work. But here's the long way to doing it. Okay?